Hi everyone, my name's Andy Masters. I'm CEO and co-founder of Inductive, and as I said, we do blockchain and artificial intelligence consultancy. I'm not a lecturer, but my wife here in the audience is a lecturer, so please go easy on me. I'm also a chess player. I've created chesschecker.com for chess players to get better at chess. I studied artificial intelligence and computer science at Edinburgh a long time ago, and I've been a coder since age 10. I've been into blockchain for about 4 years, and I recently went to the blockchain conference in Auckland and had the pleasure to spend some time with Vitalik Buterin, the creator of Ethereum, so that was quite entertaining. So let's do a quick outline. We're going to spend 45 minutes doing a whistle-top tour of Bitcoin and blockchain. It's quite a complicated topic, so I've tried to simplify things and not go into excruciating techie detail on everything. And there's lots of techie words as well, so if I say something, just ask straight away. Questions, just ask straight away, and also we'll have a bit of time for Q&A at the end. I should also point out that I'm not giving any investment advice, so make your own decisions, and yeah. So let's just do a quick audience survey. Who here is completely new to Bitcoin? One, okay, a few. Who knows a little bit about Bitcoin and blockchain? Oh wow. Who owns some Bitcoin? Does anyone own more than one cryptocurrency? Okay, oh, we've got quite an advanced audience today. So, yeah, I started getting into Bitcoin about 4 years ago, and it literally was a rabbit hole. It's so interesting, so exciting getting involved in the technology. Blockchain cuts across so many domains, it's not funny. So there's obvious domains like computer science, maths, game theory, economics for Bitcoin, and then some non-obvious domains it involves, such as business, law, energy, startups, politics. What blockchain does is it decentralizes power structures and empowers individuals. I believe it is a truly revolutionary in the political sense, technology that will radically change the way that we organize ourselves in the future. And I hope to explain why in this talk. So let's talk a little bit about Bitcoin. So Bitcoin is a new type of money. It's digital. Digital money already exists. You're probably already familiar with your bank account balance that you can go online. And it's also decentralized, which is probably the key difference. It's the first blockchain application. So the first application of blockchains is in the field of money and finance. It was created in 2009 by a pseudonymous person called Satoshi Nakamoto, and it was created just after the credit crunch. It uses clever maths to stop people from spending money twice, and there'll only ever be 21 million Bitcoins ever issued. With Bitcoin, you can now be your own bank. You don't have to rely upon anyone else. As long as you've got a PC or a smartphone, you can store money on that device. You can send money globally 24/7 to anyone else on the planet with a Bitcoin wallet. And the fees are the same regardless of the amount that you send. So that's Bitcoin. Now let's think about why this is important and why everyone's getting so excited. So when things become digital, the world changes. So you can all possibly remember the transition between CDs and MP3s. This time it's money that's going digital, and that's really going to change everything. So you can see on this graph, which if you look carefully on the left is actually on a log scale, that Bitcoin is growing exponentially. So we went through a really rapid phase initially after it was created, and now we're into a much more smooth but still exponential growth. A lot of people say exponential, and they don't actually mean it, but you can actually kind of put a formula to that and see. So if you want to have a look at the value of Bitcoin in a sort of more traditional scale, then you can see that almost vertical line that's happening right now. I think the current value of Bitcoin is about $6,000. If you'd have bought in 2010, you could have bought a Bitcoin for less than 10 cents. So that's why it's important. I like this picture anyway. I just thought I'd put it in. So the current value of all of the Bitcoins put together is $72 billion, which sounds like a lot of money, and that's why I've put that picture there. But if you think about that in comparison to the total value of all gold, it's still less than 0.1% of all the value of gold. So we've still got a long way to go, potentially. And as I said before, there's only ever going to be 21 Bitcoins available. Each Bitcoin can be divided low into 100 million parts, so they're called a Satoshi. So the relationship of Bitcoin to blockchain. So Bitcoin is the first application of blockchain technology, but you can use blockchains for other applications. And I'll talk about those in a minute. But let's talk about the problem that blockchains actually solve. So let's just come on to that. Cooperation, when we all try to get together as a group, there's always going to be some bad actors. There's always going to be people who are trying to scam the system. So in the case of money, people are going to try and create counterfeit currency and spend it twice, or there's going to be banks that issue money they don't have. So there's always going to be bad actors when you get to a big enough system. And so large-scale cooperation is a real problem. At the moment, we solve that problem by centralizing. So we have centralized power structures like governments or banks or central banks that we rely upon in order to solve this problem for us. What blockchain does is it enables us to solve that problem without a central party. It enables us to decentralize. It does this using game theory to reward individuals for behaving in ways that the designers of the blockchain want, and tries to make it so that it's economically disadvantageous to try and break the system. So let's look at the properties of a blockchain. So it probably helps if you're thinking about Bitcoin, because that's the sort of canonical example. One of the first things that we really want is a ledger. So if we're trying to keep track of who's got what money, it's easy to write it down on a book or on a block. You can think of each page in a book as kind of like being a block in a blockchain. And that book is available to everybody, so it's global. So what we're doing is we're keeping a record of all of the transactions that have ever taken place and making that record, that ledger, globally available. So it's available to everybody. It knows no borders, doesn't know about nation states or jurisdictions. And I was reading recently that somebody's even put a satellite up into space that enables people to connect to the Bitcoin blockchain through the satellites, even if you haven't got internet. So we're talking about a significant portion of the world's population being available too. So anybody in the world can, with the right access, can download a history of every single transaction that's ever taken place on Bitcoin. That would be about 125 gigabytes of data. So the other thing about Bitcoin is it's decentralized. So it runs on open source code, and there's no central control. There's no Bitcoin company. There's no single place you can go to say, right, let's shut this thing down. It's independent, and if you want to, you can spin up a node yourself. You just download the source code and run it on your computer. And so what that means is it's very resilient. If you take out one particular node, then that's not going to break the system, and other people will spin up new nodes. In fact, if you take down lots of nodes, then it becomes economically incentivized to run new nodes. So the other thing we want when we're building this blockchain is if I'm keeping a record of all the transactions that have ever taken place and making it globally available, what I don't want to happen is for anybody to start changing them. So we use this word immutable, which means not being able to change stuff. So we make it really hard to change we make it impossible to change the previous block. So we use some clever maths and cryptography to sign and hash each block as it's written, and each block is written on top of the other block, so it gets more and more baked into the system. And what this all boils back down to is by the design of the blockchain, we're designing it to work in an environment where we don't trust anyone or anything. We're working in a trustless environment. But because it's designed to be in that harsh environment, it means that we can actually trust the blockchain. Because we can trust the blockchain, we no longer need to rely on those central third parties anymore. And this leads to the most important effect of blockchain, in my opinion, which is this long word called disintermediation. So it basically means cutting out the middlemen. So whenever there's a supply chain and people are clipping the ticket and trying to extract value without actually providing any real economic input, they're vulnerable to disintermediation now from blockchain, because we don't need to trust these people anymore. We can cut them out of the loop. And that's why it's having such a massive effect in the economy. So you can think of a blockchain as kind of a mixture between a database and a network. So if you put a database and a network together, that is effectively what we end up with blockchain technology. So blocks are the data that's stored on the blockchain, and each block has got the transactions that have taken place recently in it. And each block is permanently written, so they're one on top of the other. When you actually send money, what you're doing is you're creating a transaction and you're trying to get that added to the blockchain. So you're creating a transaction and then you're sending that to the network and you're wanting that transaction to be added to the blockchain at the top in a new block. Let's have a quick look at the live Bitcoin blockchain just now. So if I So this website, blockchain.info, lets me visualize the Bitcoin blockchain. It's not the way of doing it. Anybody could write this website, so you don't need this website, but this is just a way of visualizing the blockchain. So we can see that 3 minutes ago, the 480th thousandth block in the blockchain was found. So the way that the system is designed is a new block is added roughly every 10 minutes. And we can see that in that block, 40,000 Bitcoins were transferred. So I can click on there. And it gives me some metadata about the block. So there's some cryptography and some hashing going on to kind of secure that block and prove that it's chained back to the previous one. And we can then see all of the transactions that took place in that particular block. So you'll notice at the top here, the very first one here has got a block of 15 and it's got this red line here. That's the miner's reward. So for the person who did the mining of that particular block, they received a reward of 15 Bitcoins for mining that block. So what happened there is they're trying to solve this hard maths problem in order to be able to create new blocks. And as a reward for creating that new block, they get a block reward of 12.5 Bitcoins and all of the transaction fees associated to all of the transactions that wanted to go into that block. So yeah, I'd encourage you to have a look at blockchain.info and just play around with it and see what you can find out on there.
100 grand just by doing that. Get on with it then. Come on.
All right.
Got a mortgage to pay.
So let me just.
Chemist, not computer science.
I'm just going to try and explain a little bit how that blockchain transaction works. So there's a really good book that I've read called Mastering Bitcoin, and there's this diagram behind me which tries to explain it. But before I try and explain it, I'll try and explain some of the terminology first so that you can kind of get the picture a bit better. So I'll talk a little bit about addresses, wallets, and keys. Okay, so you can think of your bank account in Bitcoin a bit like a number. So in order to use Bitcoin, you have to have an address. And the way you choose that address is you choose a number between 1 and 2 to the 256. So that's quite a big space. And the chances of anybody choosing that same number are so minuscule, it's ridiculous. It's roughly the same as winning the New Zealand lottery 7 times in a row.
Unless you choose number 1.
Well, unless you choose number 1. In fact, some people have chosen number 1 and had their money stolen because they're a bit silly. So when you choose that number, that becomes your private key. Okay, so you have the private key, and then you do some ecliptic curve mathematic cryptography stuff to transfer that private key into a public key. So you go through this process that generates a public key. With the public key, you can give that to anybody in the world, and they can send you money to that public key, and it's completely secure. So I can distribute that public key to my heart's content. It's only with the private key that I'm actually able to move funds around and to change balances. So there's 2 parts. There's the private and public part. A wallet is just a tool or a program that manages a bunch of keys and addresses. So it looks after all of the addresses. Because I don't have to walk into a bank with identity documents and go through a whole rigmarole to open an account, I just have to choose a number. It changes the way you think of the numbers. So you can create 100, 1,000 Bitcoin addresses and just use them once if you like. So you don't have to keep using the same address time and time again. So that's keys, addresses, and wallets. So let's talk about the nodes. So the nodes are the computer programs that keep the Bitcoin network going. And so that just you download a piece of open source software, and that basically has the job of collecting up all of the transactions that are being sent across the network and trying to add them to a new block. When you create a new transaction, you try and send that transaction to a node, and then it broadcasts it to all the other nodes it knows about, and then that broadcasts it to every single other node. So you create that transaction gets distributed through the network really quickly. And then that transaction is sitting in something called a mempool, which is a set of transactions that are waiting to be added to a block, but haven't yet found their way into a block. Come back to hashing. So then let's talk about mining. So mining is a bit like a giant game of bingo. What the miners are doing is they're trying to solve a hard maths problem in order to be able to add a new block to the blockchain. So the reason we do this is because if we let the same person add a block to the blockchain all the time, then they'd have control of the network. So they'd be able to choose what transactions went in, and they'd be able to say, I don't like your transaction because it came from you, or so they'd be able to censor things. So what we want to have is different people adding to the blockchain each time. And so the way we do this is by something called proof of work, which is solving this hard maths problem on top of processing all the transactions. And as I said earlier, you get rewarded with 12.5 Bitcoins for solving this hard maths problem and adding it to the block. So let's try and visualize what's going on here then. So we've got a user here who's got control of a wallet, and they've got their private keys. They decide that they want to transfer some money to somebody else. So they ask for them for their public address, which they find that out, and they create a transaction, and they broadcast that, they sign it with their private key, and they broadcast this to a node. As soon as one node gets it, it gets spread out across all the other nodes, and then a miner will try and pick up the set of transactions that are waiting and try and create a new block. Eventually, they'll find the solution to a maths problem, and they'll create a new block, and they'll broadcast that back out to the network, and it'll get added to the blockchain. So there's a lot. Yep.
Who makes the math problem?
So part of the protocol of blockchain of Bitcoin is the design of that is baked in. So what's actually happening is you're taking all of the transactions as data, as a binary string, and then you're trying to add another bit of data onto that, so that when you put it through a SHA-256 hash function, it's less than a certain number, and that's called the difficulty. So what you're doing effectively is you're adding a random string onto the end of all the transactions, computing the SHA-256 hash, and seeing if it's less than a certain number. And the only way to get an answer is to try hundreds of millions of different things to put on the end. Does that answer? Yeah.
Or doesn't it mean that in some way, in the end, somebody can monopolize this creation?
So,
Because somebody can be faster always.
so there's effectively an arms race to create the fastest machines to mine Bitcoin. So back in 2009 or 2010, you could mine quite happily on your desktop PC. You could use your CPU, and that would be fast enough, and you'd come in with like 10 Bitcoins a day quite happily. Things moved on, and somebody realized they could use a GPU instead, so graphics cards for gaming. And so there was suddenly an escalation in that arms race to get faster and faster processing. Everybody switched to GPUs. And then there's another evolution of using custom ASIC hardware to hash even quicker. So,
But that will lead to monopolization.
so
It gets more difficult, doesn't it, as it goes on?
So what's happening is as more and more people join in, the difficulty of the problem increases. And
So in the end, there will only be a few who have enough resources to be able to solve the problem.
so the cost of the hardware is probably going to be leveling off. So the cost of the hardware is pretty much the same to acquire the same mining capacity. So you could buy $1,000 worth of mining hardware today, and then you can claim that. So there is a danger of centralization, and there's different algorithms that are being developed that are so-called ASIC resistant algorithms that mean that you can really run them on a desktop PC. So they're trying to find ways of avoiding centralization. But yeah, so it is a risk. So we've talked a bit about Bitcoin. I'm just going to talk a little bit about Ethereum now. So who's heard of Ethereum? Oh, wow. So I think of Ethereum as the unstoppable supercomputer in Superman 3, but I realize that probably not a lot of you have actually seen that movie, so never mind. So you can think of Ethereum as, instead of processing transactions, the state of the blockchain is the kind of memory registers inside a computer program. So it's an unstoppable, really slow supercomputer. So it's very hard to shut it down, but it only moves forward one block at a time. So its state only updates every 11 seconds. So it's really slow. And every single node is computing the same program. So you might have 10,000 nodes running Ethereum. Every single one of those is going to run through the same program steps. So it's really, really inefficient, but it's also really resilient. So, and Ethereum is really interesting because instead of just processing transactions, it enables us to create programs in the blockchain, which really takes things to another level. You can even create other tokens, other cryptocurrencies inside Ethereum. So Ethereum can be used to create other cryptocurrencies. This is the Ethereum Alliance. So these are the companies that are getting behind Ethereum, and sort of just showing you the level of support of people who are interested in Ethereum at the moment. You might find some companies that you've heard of before on that list. So it's basically, because it's a platform, everybody's getting on board, and then people are using this platform to build new things. I'll take you through some examples of some of the programs that can be run on Ethereum. So a program that runs on Ethereum is called a smart contract. It's basically a little mini program that updates its state in the blockchain. So you would record how it operates. You'd send some code to the smart contract, and it would update the state of the blockchain, and so then the data would live permanently in the blockchain in the next block. And so it updates one block at a time. So the example I'm going to give here is movie tickets, or any kind of ticketing. I don't know if you've tried to book a concert ticket, but normally what happens is you pay XYZ for the concert ticket, and then maybe $10 booking fee, and then another $1.50 for some other fee that you didn't quite understand. So there's lots of middlemen in this process extracting value, where really you just want a ticket for the thing. So it's perfectly possible now, using Ethereum, to create a whole number of tokens that represent those movie tickets or concert tickets, and then sell them through the blockchain. So there's an application there. And the way that the smart contract's written, you could put in rules for how they're on-sold. So at the moment, people are a bit worried about scalping. You could make it so that it's impossible to on-sell one of these tickets through the smart contract. Or, if you wanted to, the creator of the contract could say that, well, the person who's organizing the contract, every time that that ticket is sold on, gets a 5% cut. So they'd actually profit every time it gets sold on. So another example is Uber. So Uber is a centralized organization. It controls the entire supply chain. With Ethereum, it's possible potentially to create a taxi booking system using a smart contract. So as an individual, you could record that your GPS position is here and you want to go to this GPS position, and that would be sent to the smart contract and written to the blockchain. And then any taxi driver, not one affiliated to any particular company, could see that in the blockchain and say, hey, yeah, I'll go and pick that person up, and see that they've picked them up, say that that's happened, and then when finally they arrive at their destination, the transfer of money can take place automatically. It would be completely anonymous because you'd only be recording these private addresses, so you wouldn't have to give up your personal details about that you were exactly at this point in time here and there. But at the same time, city planners and other people would be able to see the entire history of movements in general of people from A to B. So you could look through that blockchain of movements and work out the ways to improve the road and street design and optimize flows of traffic. Another example of a smart contract would be paying taxes. So as a contractor, you might be receiving money in dribs and drabs, and as you receive that money, some of that money really belongs to the government because you need to pay it through as tax. The trouble is that you need to keep track of how much of the money that you've got right now is yours and how much you should be paying to the taxman. And there's a danger that you might actually spend some of the money that's not yours. So what you could do is create a smart contract that says, well, when I get paid X, send it through to the smart contract, program in the rules about how taxation works to the smart contract, and then automatically send that money straight to the tax person. So you can remove all of that complication and have the money processed automatically according to a set of rules.
Well, on the flip side, use it to avoid tax.
Well, there's the other side is how does tax work? Because of this decentralization and the lack of visibility of who's sending what to who, it makes it difficult to spy on people and see what's happening. It's very similar to cash in some respects. You can download the whole blockchain and see that address A is sent value to address B, but nobody knows who owns those addresses. So it's both public and anonymous at the same time. So some of you are on the entrepreneurship course. I'll just talk about tokenization and startups a little bit. So with the advent of Ethereum, we can create a digital token that represents anything we like. So if you play some World of Warcraft game or some kind of massive online game, there might be a magical sword of destiny. You can now create a digital token that represents that magical sword of destiny and take it out of the game and actually own a digital representation of that asset. And you can then buy and sell that digital token for the magical sword of destiny to somebody else, and then they can upload that back into the game and it can be theirs. So that's just an example of what you can do. Anything you can think of, you can now create a digital token that represents that thing and transfer it between individuals. And what people are doing is people are creating these tokens as a way of crowdsourcing their startups. So people are coming up with a business plan that involves creating some kind of token of value that will be useful in the future, and they're crowd-selling it in something called an ICO, which means independent coin offering. So instead of an IPO, ICO. And the amount of money that is flowing into these things is crazy. So when I made this slideshow, the total value of all of the cryptocurrencies was $74 billion. Let's just have a quick look what the total value of all of them is today. This was about a month ago I made that slide. So we're at to $140 billion in 1 month. So it's doubled in a month, the total value of all the cryptocurrencies. And if I scroll down on this list, so this is the biggest ones, obviously Bitcoin and Ethereum, which are the ones I've touched on. If we scroll down this list, it goes on and on and on, and there's hundreds of them. So there's one called Basic Attention Token, which raised $30 million overnight. They came up with a business plan, a token offering, and they raised that money overnight. It's a completely wild west, unregulated market. It's incredibly exciting, but incredibly scary at the same time.
Question, if you make a Bitcoin, do you have to make an icon?
Well, as part of your offering, you want to have a pretty icon so that people will think it's worth investing in. So let's just go back to the sites. So yeah, check out coincap.io if you want to have a look at all of the different offerings on that list.
Would that not open up like an ability for fraud and that sort of thing? Because people are just paying to what they don't really know is...
But that's exactly what's happening. People in theory should be reading the white paper, understanding the technology, and then getting involved. Other people just go, oh, sounds like a good idea, I'll just put some money into that and this. And it goes up sometimes and goes down sometimes. So yeah, it's completely unregulated and extremely high risk. But also it means that the barriers to entry, if you've got a great idea and you want to go and crowdfund some money, you can create an ICO and suddenly you can have money thrown at you. So yeah. So let's go forwards. Yeah, we just had a look at that. So yeah, I'll just sum up. So what does the future look like for Bitcoin and cryptocurrencies? Well, banks might end up going the way of the cassette tape. In the future, our politics might change dramatically as we become less reliant upon centralized control structures. We might be able to use blockchain for voting, perhaps. We'll end up perhaps being more personally empowered, and there's going to be an explosion of startups all trying to find what works, and it's a really exciting and interesting space. So yeah, thank you very much. So any questions? Yep.
Can you explain what's happened with the Bitcoin fork and Bitcoin Cash?
Okay, right. I'll try to. So Bitcoin has some code that works that says how Bitcoin works. And one of the problems with the way that Bitcoin works is that the blocks have got a limit of 1 megabyte in size. That means there's only 1 megabyte that can be used to put all of the transactions that people want to put in for the past 10 minutes. And so what's happened lately is those blocks have started filling up. And so most of the blocks have been almost 1 megabyte. And then people are waiting around for ages trying to get their transactions processed. And so there's been a big argument in the community about the solution for how do we resolve this. And so the fork has been as a result of 2 different groups of people coming up with different solutions for solving this argument of how do we make Bitcoin scale so that it can process more transactions. So Bitcoin Cash has gone to the route of making the blockchain have a block size of 8 megabytes instead of 1 megabyte. So that's Bitcoin Cash. And then Bitcoin, the traditional one we think of as Bitcoin, is going for something called SegWit and making the blockchain, the block with 2 megabytes in size. So there's just been this disagreement, and 2 different groups have said that they want to do things in a different way. And so we've had to fork. Does that answer things?
Yeah, so which one is the best one, do you think, to follow?
I wouldn't say best, but if you look at the valuations in the market, the traditional Bitcoin is worth 10 times more than Bitcoin Cash. So that's where the market at the moment thinks the superior technology lies. That's not to say things might change in the future.
Andy, you mentioned about Bitcoin and Ethereum.
Yep.
From that list there, was there any other particular cryptocurrencies or technologies you reckon's worth looking at?
So if you think of the space of trying to design a blockchain, you're trying to get it to solve a problem. And so Bitcoin's got a really good niche. It's the first, and it's first to market, and it's solving storing value and transferring value. Each other thing that comes along has to answer the question, what job am I existing for, and how well do I operate in that space? So you can measure like how fast are the transactions, how does it mine. There's all these design parameters that go into things, and so you really need to try and say what problem is it solving, and is it doing a good job at that. There's things like Zcash and Zcoin which value privacy, and so they create a system which is almost impossible to track any of the transactions. There's another one called Litecoin which has much faster transactions than Bitcoin. So depending upon what you're going for has different appeal, and so really trying to find which particular niches appeal to you and what you think the market's going to find. There's other technologies. There's one project I'm looking at called MadeSafe, which is creating something called data chains, which is kind of an evolution of blockchain, and that's quite cutting edge stuff that I'm looking into as well at the moment. Yep.
What are some of the main reasons blockchains fail?
Okay, why blockchains fail? I suppose
Cryptocurrencies, right?
if nobody's mining them, so if nobody's interested, then eventually the value of the coin or the token will fall in value, and then the reward for mining that particular thing, which is paid in that token, will go down. And so I suppose once it reaches a certain threshold, then nobody will bother mining that particular token anymore, and so you won't get any more blocks. And if you don't get any more blocks, nobody will be able to do anything on that particular thing. So basically, if everybody loses interest in it, it will stop. Nope, done.
Andy, what's the situation about capital gains tax? We don't have a capital gains tax in this country, but if I bought 10 bitcoins in 2010 and I've now got $5 million,
Yep.
surely in most regimes I'll become eligible for some kind of taxation.
So I'm actually talking to my accountant at the moment to try and work out what's happening on that. The answer is I don't know. I think it depends which country you're in. And yeah, it's complicated. So I think the whole legislation and taxation and meeting this particular technology is going to be very complicated. And because it's moving so quickly, by the time regulation manages to regulate one particular thing, the technology will have moved on leaps and bounds. And so there's always going to be this catch-up that's going to be lagging behind.
Given that the technology is progressing the whole time, isn't it likely that at some point somebody will be able to change the blockchain?
So
The blocks that you have now will disappear at some point.
So the way that the blocks are written is the amount of computational resource that's been expended in order to be able to create that block gets harder and harder. And so in order to rewrite a particular block on the blockchain, you'd have to expend that computational resource, which is getting harder and harder and harder. So some people are worried about quantum computers being able to break ecliptic curve cryptography and be able to go. So there are some risks in that if we have some massive technological leaps.
Is there a fixed amount of Ethereum, like there is a fixed amount of Bitcoin in the world, or is it kind of expanding?
I don't think there is a fixed amount of Ethereum. You've actually got me on that one. I don't know the answer to that, sorry.
Although cryptocurrencies seem to be a great way of obviously being able to hold value and being able to transact value between different people, in terms of from a finance perspective, how does that work in terms of interest in rewarding people who lend cryptocurrency to others for use, and how do you control that when you don't have centralized authorities that will monitor that?
Okay, so I suppose the important thing to say is that there's no central interest rate built into any of these currencies. So you don't get a return for doing nothing by holding cryptocurrency.
Yeah.
But in the same way, you can get a return by taking some kind of economic risk. So I can lend you some cryptocurrency and I could charge an interest rate on that, and I get a reward for taking that risk.
Yeah.
But there is no central base interest rate.
Yeah, absolutely. But how do you enforce that though?
So in the same way we enforce things in the real world. So if I lend you some Bitcoin and you don't give them back to me, then I'm going to be displeased and send the...
Yeah, but wouldn't that make it a much harder Wouldn't that make it a much harder process, especially for people who are wanting to lend smaller amounts, when like litigation costs would actually be a lot higher than maybe the value of Bitcoin they borrow?
So I think the sort of the lending side of things, I think there's some startups that are trying to work in that space, and but I think the thing to realize is everything eventually touches the real world, and so you can't solve lots of problems with just technology on its own. Oh,
You can make a smart contract for interest in loans, right?
you could.
You just couldn't force the repayments, right?
So you could create a smart contract for interest and loans, except the money would be looked after by the smart contract, which wouldn't suit anybody. So you'd there'd be two of us, and the smart contract would look after the money, but neither of us would be able to access it, which would kind of suit neither party. So you could enforce it, but it wouldn't be very useful. Okay. Oh, one last question.
What happens once they reach the limit for the amount of bitcoins they can have?
So what's happening is remember I said the miner gets a block reward of 12.5 bitcoins. Roughly every 4 years that halves, and the reward keeps going down until eventually the reward for finding a new block on the blockchain goes to 0. At that point, the reward for mining a block on the blockchain is only the fees attached to the transactions. So you still get a reward, you just don't get a kind of bonus of however many 12.5 bitcoins this is at the moment. So you still get a reward, it's just it's 0 from a bonus point of view.
But you said you can only have 21 million Bitcoin.
You can only have 21 million, but the fees come from people who've already got Bitcoin. So if I'm sending a transaction from A to B, so there's about 18 million issued Bitcoins at the moment. So we're almost up to 21, I think. Yeah.
In terms of like, sorry, this is probably a rookie question, but like, how much like processing power does it actually take to add a new block to the blockchain?
So it's designed to take about 10 minutes, and we have pools of hardware that it takes a serious. I don't know exactly how much energy and how much it takes a serious amount of computational power. Like we're talking like exahashes a second. Yeah, so we need a machine that can compute exahashes a second in order to be able to.
And also, just in terms of like talking about. In terms of like a cyber terrorism sense, could there be risks in terms of if, terrorists would actually use to basically take down that network because it's all based with electronic components? Could there be serious complications, like especially if it's over a wide scale area?
So I suppose the decentralized nature of the network makes it resilient to most forms of attack. So if one particular portion of the network is isolated, say there's an EMP strike or something, the rest of the network will still go spinning on. So it's designed for resiliency. It's probably more resilient than your traditional fiat currency.
It's a mesh network.
Effectively, yeah. Are we done with the questions there?
Just one more. So what incentive does government have to get involved and support this if they can't control it?
That's an interesting question. I suppose if you're a free state and you're encouraging democracy and liberal thinking and people to express themselves, then you should be encouraging this kind of development.
You've got future. Definitely got future in Wellington.
I have one last question. So, how do you recommend we invest and get involved with the blockchains like Bitcoin?
I thought that question might come up. So there's a few websites there that are interesting. So if you want to get a wallet so that you can actually transact with Bitcoin, you can download one of those apps there, and there's various other ones like Jaxx. So that means you can actually transfer money and use Bitcoin. You can read the white paper, which is up there. And if you want to actually get some Bitcoin, I would recommend the best way to get Bitcoin is to find a friend with Bitcoin and transact that way, because that way you kind of trust everything. You don't have to go through lots of complicated things. There's also a couple of websites there that I've used before for buying and selling Bitcoin. Cryptopia is based in Christchurch in Addington, and it's the 40th biggest cryptocurrency exchange in the world, and it's based in Addington down the road, which is quite amazing. All right, thank you very much.
Great. So